Somewhere in the direction of the constellation Scutum lies a star so enormous that it completely reshapes how people think about stellar scale. This star is known as UY Scuti. At first glance, it might sound like just another distant point of light among billions of others scattered across the sky, but the truth is far more astonishing. UY Scuti is one of the largest stars ever discovered in the known universe. Its radius is roughly 1,700 times larger than the radius of the Sun. Numbers like that are difficult to grasp, so astronomers often explain it differently. If UY Scuti replaced the Sun at the center of the solar system, its outer atmosphere would extend beyond the orbit of Jupiter and possibly approach the orbit of Saturn. In other words, nearly the entire solar system would be inside the star. Now imagine approaching something like that in a spacecraft. Crossing the distance to a giant. The journey toward UY Scuti would begin like any other deep space voyage. From Earth, the star lies roughly 9,500 light-years away, hidden within the crowded stellar fields of the Milky Way. Even powerful telescopes struggle to isolate it clearly because of the dense clouds of dust and stars along our line of sight. As the spacecraft approaches from interstellar space, the star would slowly grow brighter. At first, it would resemble any other distant red supergiant, a glowing reddish point surrounded by darkness. But unlike ordinary stars, its apparent size would increase more rapidly as distance shrinks. That is because UY Scuti is not just bright, it is enormous. Millions of kilometers from the star, the view would begin to change dramatically. The expanding wall of fire. Approaching UY Scuti would feel less like approaching a star and more like approaching a glowing cosmic horizon. Unlike the Sun, which has a relatively compact and well-defined surface, red supergiants have enormous, diffuse atmospheres. Their outer layers are extremely thin and extend far into space. From a distance of several astronomical units, the star would already dominate the sky. Its surface would not appear smooth. Instead, gigantic convection cells would churn slowly across the stellar atmosphere. These cells are vast bubbles of hot gas, rising and cooling, each one possibly larger than the entire orbit of Earth. The color of the star would appear deep orange to red because its surface temperature is relatively cool compared to smaller stars. Yet, despite that cooler temperature, the star shines with hundreds of thousands of times the luminosity of the Sun. The sky would be filled with a slowly boiling ocean of stellar plasma. A surface larger than the solar system. As the spacecraft continues closer, the true scale of the star becomes overwhelming. UY Scuti is so large that light itself takes hours to travel across its diameter. A beam of light leaving one side of the star would take several hours before reaching the opposite side. From close range, the curvature of the star would barely be noticeable. The surface would feel like an endless glowing landscape stretching across space. But unlike a solid surface, this region is actually the outer atmosphere of the star. Gas densities here are incredibly low compared to planetary atmospheres. In fact, some parts of the star's outer layers are less dense than the vacuum inside laboratory chambers on Earth. Yet the temperature still reaches thousands of degrees. Any spacecraft approaching this region would encounter extreme radiation and turbulent stellar winds streaming outward into space. Storms larger than solar systems. The surface activity on a red supergiant like UY Scuti dwarfs anything seen on the Sun. The Sun produces sunspots and solar flares, but these features are tiny compared to what exists on a giant star. On UY Scuti, convection cells may span hundreds of millions of kilometers. These immense structures move slowly across the star's surface, carrying hot plasma upward before it cools and sinks back into deeper layers. The motion is so vast that the entire star seems to pulse and breathe. Powerful stellar winds constantly blow material away from the star. Each year, UY Scuti loses an enormous amount of mass, ejecting gas into the surrounding interstellar space. Over time, this process forms an expanding envelope of material that surrounds the star like a colossal fog. Flying through that region would feel like navigating through a glowing stellar storm. The instability of giants. Stars this large live fast and unstable lives. Unlike smaller stars such as the Sun, which can burn steadily for billions of years, red supergiants exist only for a brief moment on cosmic timescales. UY Scuti began its life as a massive star many times heavier than the Sun. Because of that high mass, its core burned through nuclear fuel extremely quickly. Over time, it expanded dramatically, entering the red supergiant phase where it now exists. But this stage cannot last long. Deep inside its core, heavier elements continue forming through nuclear fusion. Each stage of fusion lasts shorter than the last. Eventually, the core will reach iron. And when that happens, the star's story changes completely. The future explosion. Iron cannot release energy through fusion in the same way lighter elements can. Once the core of a massive star fills with iron, fusion stops producing outward pressure. Gravity suddenly wins. The core collapses in a fraction of a second. This collapse triggers one of the most powerful events in the universe, a supernova. If UY Scuti explodes as a core collapse supernova, it will briefly outshine entire galaxies. The explosion will eject vast amounts of heavy elements into space, enriching the surrounding regions of the Milky Way. Those elements may eventually become part of new stars, planets, and perhaps even life. The giant star that once dwarfed the solar system will vanish in a single cosmic catastrophe. The legacy of a giant. Stars like UY Scuti play an important role in the evolution of galaxies. Through their stellar winds and eventual supernova explosions, they distribute heavy elements across interstellar space. Carbon, oxygen, silicon, and iron all originate inside stars like these. The atoms that make up planets and living organisms were forged in ancient stellar furnaces long before the solar system existed. In that sense, even a distant giant star contributes to the ongoing story of the universe. UY Scuti may appear as just a red point of light in a crowded star field, but its true scale and power are almost beyond comprehension. It is a reminder that the universe contains structures far larger and more extreme than anything encountered in our small planetary neighborhood. And somewhere deep inside the galaxy, this colossal star continues slowly burning, swelling, and shedding its outer layers, preparing for a final explosion that will reshape everything around it.